Our next speaker is Ray Idaszak. He's from RENCI at UNC-Chapel Hill. His title is HydroShare and IRODS, How IRODS Manages Data for a Hydrology Community of Thousands of Users. And he has his own microphone.
Okay. Hello. So this talk is to help you build communities and show you how we built a community where the back end of the system is supported by IRODS. The people that are associated with this, if their names are underlined, they are in attendance here, so feel free to talk to them here or afterward. So HydroShare is a platform for sharing resources and collaborating, has a Dropbox kind of functionality. You can drag and drop things to it. Metadata, REST API, apps, kind of an app store kind of function, social functions. You can comment and rate on resources and publish things with the DOI. And as of yesterday when I looked, we do use Kibana to keep usage metrics, so we're over 2,000 users. So it's a good sized community. There are smaller communities, there are larger communities, but we're kind of right in that mix. With our system, we do releases every 4 to 6 weeks, so it's kind of a parallel research track and a production track. So we definitely support this as a production environment to the community, but in parallel, we are, have a nice continuous integration pipeline so that with unit tests and, and so forth, code reviews and whatnot, to put quality releases out so that this, system can be robust for the users that we support. And normally I would put this at the end, but if you would like to know more about HydroShare and IRODS, I refer you to this 2018 paper by Dr. Hong Yi, who's in attendance and from our team here. Advanced Distributed Data Management for HydroShare Hydrologic Information System. It's part of an Elsevier publication of environmental modeling and data systems and does a really nice deep dive. If you don't remember the DOI, I've pointed a bit.ly URL to it, HydroShare and IRODS, so it's easy to remember. You would need to use your institutional login because it's an Elsevier publication, but hopefully you can download it that way. Okay, so some of the capabilities that we're supporting so that you can kind of get a feeling for what we support, and perhaps as you build your communities, you'd be able to support similar things, is that through this system, we support data and models. So models meaning, hydrologic models, the models that are popular that the community supports. We have access controls. We can manage who has access. We have the notion of an owner, which can grant other people privileges, and there can be multiple owners, or people can just view and edit the resources. We have the notion of a group, so groups can also be, a group at a time added to the access control. We have a design philosophy that every capability or every feature that is represented or surfaced through the web user interface has a parallel with the REST user interface, so you can always access this capability with the REST API. We have the ability that, since it's a production environment, we have the ability to take the data that you offer to your community and mint a DOI to it, at which point it becomes immutable and citable. And we also have the ability to take within a single resource, to drag and drop input data, the model that can act on that data. We could run from that resource landing page, we can run the model against that data, and then through the REST API, we can, take the output data, bundle it all together, publish that, and that becomes a nice little reproducible unit that others can discover and build on. And then we also have this notion of the app store, so it can be a thing like Jupyter Notebook, so that once you have the output data in that resource, you can open up something that can spin up a Jupyter Notebook to act on it after the output data is done from the model and analyze it and use it for things like visualization. So this is a really high level but simplistic view. So we have HydroShare is built in Python and Django. The IRODS network, our PI calls it the network file system, distributed data management. And we do use the federation capability to go between where we store the resources proper that our users are storing, publishing with GWIDs or DOIs and whatnot, and a user area that sort of so as to protect that. The canonical data from the user area where they can use it as a staging ground or a place to put intermediate files. Okay. Now I know this is towards the end of it, so likely the positioning of my talk has meant that you have seen a lot of the capabilities of IRODS, but one thing I would encourage is that, I actually stored these slides on HydroShare itself because it's intended for that. So the idea is that the slide deck is standalone. So, a user that subsequently, discovered it. So I may not go as deep a dive in this because I know you've likely seen this, but we use the IRODS for one of its premier features, which is data virtualization. Same thing here, our zones can span multiple geographic locations across the United States, which in fact we do. Some in Alabama, some in Illinois, obviously a lot in North Carolina. And these capabilities, so in addition to virtualization, we have the ability to have rule, triggers, policy enforcement points and whatnot in the federation that I mentioned, and the access controls. So the next thing I would say is that if you're building a community, make it very easy for them and seamless to access IRODS as if they were accessing any other file. So the interface shown on the left, I think you can see there, it has a drag and drop interface behind the login to IRODS that I've kind of amplified or magnified there. So you can take any file on your desktop and drag and drop it. So that's sort of the easy Dropbox kind of functionality. But in addition, we can have this button that's right there that says log into IRODS. And so it's in the same sense that you can have the same interface to access a file from your desktop, we expose and make it very easy for a user to authenticate in IRODS and get to that. And that's good for use cases for us because a lot of people in the hydrology community, a lot of the use cases are large, let's say they have a 10 gigabyte file and it's hard to get that through the system in HTTP. Well, if they get it into IRODS, then from IRODS we can ingest it directly at the rate, the great rates of speed that IRODS offers right into HydroShare. The other thing is that make sure that the capabilities that you're offering to your community have very good help pages. So in terms of how we offer these capabilities in IRODS to our community, we have very well spelled out help pages to show how to use the IRODS features. And on that particular help page, there are 3 at the bottom that I highlight. So now I'm going to show some of this, from the standpoint of what does IRODS really look like at the back end. So in the case of HydroShare, I mentioned this app area, sometimes app portal, sometimes they're referred to as like an app story. So you can kind of see that there's different applications in that app portal. One that I'll focus on is the National Water Model. So you would select that app, and that would act on particular data that you would store, that the community would store either individually as a group, as a resource. Okay, so here is the federated backend. It's not quite exhaustive, but it's most of it. So we have HydroShare, which is the Python Django, and it's backended by IRODS. In a loosely coupled architecture, we also have the App Store, which is based on a Tethys. Tethys is a framework out of BYU, which is one of our collaborators across the award. So, and then CyberGS is a technology and a partner as part of our NSF award from NCSA. So across this IRODS federated distributed data management middleware, we have something called the National Water Model Zone. So that, and it's its own zone, right? And it's federated with the HydroShare zone, which is where all the resources are stored. So in the National Water Model Zone, we have a script that goes to the kind of things, the kind of high value data sets that we offer our community that are large, right? So we have a script that goes out and grabs the National Water Model, which is computed at NOAA daily. Okay, so they have hourly forecasts. And what we do, and they're in Maryland, so what we do is once a day, every hour for short and medium forecast data, and once a day for the long term, because that's how often it's computed, we scrape that data. And it turns out to be like a terabyte a day. And we scrape that data, but because what they do in hourly forecasts is they do it as a rolling window. So that rolling window, when the 25th hour comes up, that first hour there rolls off forever. It's gone, right? So you have this rolling window through time of just the 24 hours, the current 24 hours of those hourly forecasts. But there are events like hurricanes that are of tremendous value to the research community that we want to snapshot, right? So the first thing we do is, which we exploit this, the federation capability and the various features, high speed throughput and so forth, transfers, is to extend the 24-hour window to 40 days, okay? So now we have a 40-day rolling window, and we put that in our RENCI headquarters, as part of a storage area there that was supported financially by the National Consortium for Data Science at RENCI. So now we have this 40-day window, which is much more valuable to the community in terms of having a high-value, rich data set that they can hit, but without trying to grab it in the 24-hour window that it's only available from NOAA. Then the next thing is, so we have a 40-day window, but that starts to roll off. So what we do is we archive within IRODS, within that NWM zone, National Water Model Zone, is we have a 24 terabyte area for hurricanes. So we archive, since we have the national water model data, it's like the whole United States, we archive all the data for a little bit before the hurricane begins and a little bit after it concludes, and we snapshot that hurricane, and it becomes a high-value data set to the community. Okay, so we did that for Harvey, Irma, and Maria. So those data sets are now these very large, rich data sets that through that login to IRODS can be accessed and ingested directly into the resources for people to do their research with models and whatnot, analysis tools. There was a workshop that was supported in 2015 called NIFI, it's National Flood Interoperability Experiment. So we had a federated zone that went to NCSA and University of Alabama. It's still active today. So the data and the products produced by the students then are still available today. We have the HydroShare user zone, which I mentioned earlier. So as to protect the resources that have to be preserved and served up through DOIs, so they can't be modified. So we keep those core golden resources in HydroShare zone, but so that there is an area that the users can stage things and upload their own large files, we have HydroShare user zone. So we federate all this across the back end of HydroShare and make the proper area for storing those HydroShare resources is 50 terabytes. And we use, actually, for disaster recovery, because it's a production environment, 4 miles away, we use the replication service in IRODS to, anything that happens in HydroShare is synchronized and replicated 4 miles away, so that if, should something happen to the, the core data set, we've exploited HydroShare property of replication to have a disaster recovery backup that's available. Then going forward, this is also in, okay, so this is Linus. So this is in the paper I mentioned earlier that goes into this concept much more detail that I mentioned from Dr. Hong Yi. What we're looking at in the future is to say, okay, so we have what we were funded for by the NSF, which goes from 2012 to 2021. It was just recently renewed, so it's quite a long track. And one of the things we're looking at is, let's say our 50 terabytes isn't enough, that you're coming to the table with a 100 terabyte use case. And they're out there. There are satellites that are about to be launched that will generate a lot of data that would exceed what we're funded to support within our 50 terabytes. So again, how can we exploit IRODS capability to support this community of a couple thousand users and growing? And so there's this notion of you bring your own zone to the table from your campus, back-end it by your support, your quotas, your IT staff. It's your 100 terabytes, and the resources there, the resources that are ingested or the high-value data set that you bring to the table is stored on that, but can be made part of the ecosystem with the same set of users, the same policies, the same ingestion, the same user interface and whatnot. So this is something that is attracting a lot of interest to our community. Okay, to learn more, I put some links there. These slides I made a bit.ly link, I didn't put that there, but the slides are stored in HydroShare itself, because that's the way we use it. But the bit.ly link is bit.ly/HydroShare IRODS UGM 2018. HydroShare IRODS UGM 2018. Okay, that's our team, and that is it. So, questions?
Are there any questions about HydroShare? So this has been 5 years now. Is that what you said?
Yeah, 2012.
Wow.
So, and that goes. It's funded through 2021.
Pretty good.
Okay.
All right. Thank you.